Hello everyone, welcome back to our channel Geomatics Engineering. Here we learn and explore the things related to geomatics engineering. This is our next video in module land surveying on the topic trigonometric leveling. So it is very easy topic and it can be done if you know your +2 concept of trigonometry very correctly. So in this topic we will only apply trigonometry and we will calculate the level at different points. So what is trigonometric leveling? We have seen already leveling and different types of leveling methods in previous lectures. In leveling we are used to calculate the levels, which we call it height from mean sea level. In leveling we do this. In trigonometric leveling we will do the same thing. We will calculate height, but here we will take use of linear measurement and angular measurement both. Here we will take use of linear measurement and angular measurement both, and with help of these two we will calculate the height of point, or we can say height of tower, RL of point at some height. So in both things we can do. So let's read down the definition written here. Trigonometric leveling is the process of determining the difference of elevation of stations from observed vertical angles and known distances. Means we have to calculate vertical angles and known distances. By using these two we will calculate the height. Vertical angles are measured with help of accurate theodolite, and horizontal distance can be measured by using chain, tape and EDM, any horizontal distance measuring instrument. So let's move on in trigonometrical leveling. It is very easy, and just if you know the concept of angle of elevation and angle of depreciation, then you will solve the whole trigonometrical leveling questions very easily. So let's start. You can see in this figure theta is the angle of elevation here, and this much height is represented by this d into tan theta. So in same way we will do the whole thing. Just let's see them one by one. In trigonometrical leveling we are going to deal with three types of different cases. The case first is if base of the object is accessible. Means if you are seeing a tower and this base of object is accessible, means you can measure the horizontal distance from this base of the object where you have set your tripod and where you have set your station, and the distance between these 2 points, if you can calculate it, then it comes under the first case, that base of the object is accessible. Another case is base of the object inaccessible. Means for example there is an mountainous area. Here you have to calculate the RL of this point A. Now if you have set your tripod and theodolite here, so you cannot calculate the horizontal distance between the base of the object. You cannot calculate this distance. So this one is the second case, and in second case there are further two more cases that sum up to three cases. That first one is if we will take use of multiple what we say, we will take use of two stations. For example, one station is here and another station is here. Now we will use two different position of theodolite, and then we will see that calculation. So if these two positions are at same level, means line of height of sight is same, then it comes under the first case of second case. And if these two stations are at different level, means one is at different height and another one is at different height, then this comes under the another case. So we will see them one by one. Just here I am trying to say that we are going to deal with three cases. First one is very easy, when base of object is accessible. Next one little tricky, that base of object is inaccessible, and in that one there are two sub cases, that stations are at same level, means two multiple position of stations are at same level, and next one is two multiple position of station are at different level. So let's do that the calculation part one by one for each case. First one, base of object is accessible. So I am going to draw the figure. So this one is our first case, when base of the object is accessible. This is an tower. Here point A, we need to calculate the elevation of point A with respect to mean sea level. Here we have some point benchmark whose elevation is known. For example, let assuming it elevation of this point is RLS benchmark. So what we did, if bottom point, that is base of the object, if accessible, then first we will set up our tripod and theodolite at some distance, and we will calculate the horizontal distance between this point. Let name it is just below the A, then A dash, this point, and from the center of the tripod we will calculate this distance as D by using any kind of linear measurement. Then by using theodolite we will measure this vertical angle theta, and side the point A here, Now we know by applying simple trigonometrical equation that tan theta will be equal to what? If I am assuming it h, tan theta will be equal to h upon d. See in this triangle, tan theta is equal to h upon d. So here we get value of h, that is d tan theta. Now we know this much height h. So if we will calculate the height of instrument means height of line of sight from mean sea level. From mean sea level, if we will calculate the height of line of sight, if this is our mean sea level, and if we are able to calculate the height of instrument, then we will add up h and we will get the RL of A. So we know that already in leveling, height of instrument is calculated by taking back side at benchmark, and here back side is S and RL of benchmark is RLS. So we will write down that height of instrument will be back side at S plus RL of benchmark, that is RLS. So it comes up to RLS plus backside, that is S here. Now we know that A point is h distance above from this line of sight. This is our line of sight, and A is h distance above line of sight. So we can write down RL of A will be equal to h plus height of instrument, and finally our RL of A will come out to be d tan theta plus RL of benchmark, that is RLS, plus backside at benchmark. So in this way we can calculate RL of any point at some height by using trigonometrical leveling. Also, for example, if we need to calculate the height of the object, this object only, the complete height, if we need to calculate that, so it is much more easier than this RL calculation. What we will do, we have calculated this theta by taking elevation angle. We will calculate another theta by sighting the bottom of the tower and write it down, theta 2. Now this much height will be h2 and h2 will be equal to d into tan theta 2, similarly as h is equal to d tan theta, and total height h here is h plus h2 and it becomes d tan theta plus d tan theta 2. So in this way we can calculate the height of tower also. So this is all about first case. And just think, is it very tough? I did nothing, I just applied the trigonometrical formulas here and calculated out the RL of point A. You have, if someone asked you that give me the RL of point A dash, you can do this also. You can do this also. You can calculate the RL of point A dash also. You will just subtract the height of tower from the RL of A. I am writing it here. Hope you will get it. If someone asks you RL of A dash, so just it is RL of A minus height of tower H. So you can calculate it also. I am representing this line as a straight line, but it is not straight all the time. There will be some undulation between them. So it is not necessary that A dash and benchmark will be at same level. Just keep it that mind. Now moving further to our next case. That is, base of object is inaccessible and stations are at same level. So first I am going to draw the figure of it. So let me draw the figure. So this one is the case of base of object is inaccessible and stations are at same level. See this, we cannot reach the point A dash here, so we cannot calculate this much distance here, and we cannot calculate further calculation just in similar to the same previous case. So what we will do in this case, we will move our instrument up to certain distance D and set up again, and we will take the readings again. So here we will get multiple readings. Here I will get theta 1, here I will get theta 2, and in this case our both the position C and D of the tripod are such that it having same sighting at the benchmark, means their line of sight, yeah, height of instrument, what we call height of instrument is same, means both the positions are having same height of instrument from mean sea level, means the HI value is same for both the positions C and D. Now again here H is missing, this one is the H. We have to calculate the RL of A. So let's do it. How we will do that? Do the calculation. Now first see in this triangle, the first one, which makes angle theta 1. We don't know the distance, this distance, so I am assuming it right now. I am assuming it that this distance may be d dash. Now keep it man, I am assuming it d dash. So at the last I need to remove the d dash because I don't know what is the value of d dash. So if this one is the d dash, and by using this triangle, I am naming it, let me use a different color, PAQ. In triangle PAQ, we can see H will be equal to d dash tan theta 1. So in this equation first, in this equation I have d dash as unknown and h as a unknown. Now I am going in triangle, let's name it RAQ. Here the horizontal distance is d plus d dash and height is same h, and now angle of elevation is different, that is theta 2. So here we will get the equation of h is equal to d plus d dash into tan theta 2. Now you know we are getting here also d dash and h as variable. There are two variables and two equations. We will substitute the value of d dash from first equation into second equation and we will get the value of h. From first equation I can write down d dash is equal to h upon tan theta 1. I can write down. Now substituting this value in this equation, so I will get h is equal to d tan theta 2, d dash is equal to h upon tan theta 1, so it will become tan theta 2 upon tan theta 1 into h. It will go there and h will come out to be so h will come out to be tan theta 1 into tan theta 2 upon tan theta 1 minus tan theta 2 into d. So this will seems to be very hard equation to learn. So I will say do not learn this equation. Do not learn or do not remember this equation. Why? Just remember the step how I did. I first make the equation 1 and then I made the equation 2. If question will come, just make the equation 1 and equation 2 and substitute the value of d dash. From first equation to second equation you will get the value. If you will try to learn the equation and remember it, it will make you tougher and you can have mistake, you can make mistake from it. So just remember the process, and once you get the value of h, again RL will be same, RL process will be same. RL of A will be RL of benchmark, again RL of benchmark, that is RLS plus S distance backside, that is height of instrument, and plus H. This is the same as the previous case, and you will get the RL of point A. So in this way, case second first part is going to happen, and here also I did nothing, just applied the trigonometrical equation. I got here two variables, I solve them and get the value of h, and from the value of h I got the RL of point A. Now the last case is that both the stations will be at different level. Let's draw the figure. So this is the third case and the last one, where both the stations are at different height, different level. You can see at benchmark, the readings are different for both the positions. Here S2, here S1, means height of instrument for this position is different and height of instrument for this position is different. So we can by using multiple readings we will try to establish some equation and we will get the value of RL at point A. So first just make you understand that here base is inaccessible, you cannot calculate this much distance, so I am assuming it again as a D dash, just like the previous case, D dash. What we can calculate, that is theta 1, theta 2, S1, S2 at the by taking backside at the benchmark, S1, S2. So first just try to understand that S1 minus S2, that is representing S, it is the difference of height of instrument between both the points, both the station level. This is the difference of level at both the station points. And here H2 minus H1 is also representing the same thing. H2 minus H1 is also representing the same thing, the difference between the height of instrument of the both point. Try to see here that H2 minus H1 is also this gap and S1 minus S2 is also this gap. So first we got a relation H2 minus H1 is equal to S1 minus S2. Let's see, maybe if we will have a use of this relationship. Now let's calculate one by one. First, from this triangle I am naming it again P point, P, A and Q, PAQ, in triangle PAQ. What we will get? We will get, this is the length D dash, this is H1, so we will get H1 is equal to D dash tan theta 1. Here theta 1 is known, D dash is unknown, H1 is unknown, so I am replacing D dash as H1 upon tan theta 1. Okay. Now let's see in another triangle, that is triangle RAS. RAT. Let name this RAT. In triangle RAT. In triangle RAT, don't go with the names, just grab the concept. This distance is what? From R to T. This distance is D plus D dash. D plus D dash will be equal to what? If I will take tan theta 2, then it will be equal to perpendicular upon base H2 upon D plus D dash. So I am finally writing it as a equation, that it will become H2 is equal to D plus D dash into tan theta 2. So in this equation, theta 2 and D is known. You can measure the horizontal distance between C and B, and you can measure the angular measurement theta 2 from this point, angle of elevation. So here D dash and H2 is unknown. So I can put the value of D dash here from this equation. So I am writing it down, equation 1, equation 2. Equation 1, equation 2. Also you can measure the value of S1 and S2. You can measure the value of S1 and S2. So from this condition, S1 and S2, you can write it down, H2 minus H1 is equal to S, and H2 is equal to S plus H1. So this one is the third condition. So I am having here D dash, H1, H2, 3 variable, and also I am having equation 1, equation 2 and equation 3. So 3 variable and 3 equation. If you are an engineer, you know how to solve 3 variable and 3 equation. So by substituting the value of H2 from equation 3rd in equation 2, and by substituting the value of D dash from equation 1 in equation 2, we will get the value of H1, and once we got the value of H1, the remaining portion will be same for RL of A. I am not going to write the formula, generalized formula, or what you call it, a perfect formula for H1, because there is no formula going to work on you. Just remember the trigonometrical leveling concept, that you applied the trigonometry and calculated out the H1, unknown part of the portion, and once you calculated out the H1, the RL of A will be what? That RL of A will be this height of instrument of this position, that is position B, HIB, plus H1. I am writing it here. RL of A will be this height of instrument. I am naming it HI1. HI1 plus H1, and HI1 will be what? HI1, if RL of benchmark is RLS, then HI1 will be RLS plus S1. So finally RL of A will become RLS plus S1 plus H1. So in this way you can calculate the RL of point A. So these all are 3 categories, or we call it 3 cases of trigonometrical leveling. They all are very easy. Just you need to understand that you have to apply only trigonometry, and you have to calculate linear measurement and angular measurement. Just remember, in the case of accessible base, you need only one station position. In case of inaccessible base, you need two stations position, and between those two station position you measure the linear measurement distance d and angular measurement theta 1 and theta 2, and by making up the equation you remove the variables and get the required variable and calculated out the RL of point A. So this is all about from this lecture, trigonometrical leveling. It is very easy topic. I am going to put some questions in the Telegram group. Go solve them. If you are not able to solve those questions, and also I will give the answers of them also, so that you can match your answers with your original answers. If you are not able to give the answers, then tell me. I will make a separate video of doing calculations and questions. In that I will tell the answers of trigonometrical leveling. So till then, keep up. Gate is very near, and some of the students was asking about that, sir, please complete the syllabus. I must say that we are going through a hard phase. Our faculties are busy in something, so we are working to complete the syllabus, but if some portion remains uncompleted, then don't see them. Your already syllabus is more than 80% completed. We are just finalizing it. I have started photogrammetric module already. That photogrammetric module will give you around 5 to 10 marks from that module. And some students are asking for mathematics portion. We are trying to complete the mathematics portion, but keep in mind that just unlike civil engineering and mechanical engineering gate exams, in this gate exam, GE gate exam, mathematics is not going to come off 15 marks. It is not like this. Only 4 to 5 marks you will get from maths. Only 4 to 5 marks, maximum 5 or maximum 6. But except other, if you will compare with other subject like land surveying, which is going on, land surveying, photogrammetry, this both will combine up to 30 marks minimum. I am saying minimum 30 marks you are going to get from these two subjects only. So we are trying to complete your syllabus, but just keep on focusing those areas which we have been uploaded, and don't bring any negativity that this syllabus is untouched or that syllabus is untouched. Already we have completed 80% of syllabus in our YouTube channel. So go with that and have a great score. So keep on practicing, and if any suggestions you want to give us, and any kind of thing, so just let us know and go through the Telegram group. We are going to upload some questions also there. So have a good day. Stay updated.